Alright guys, so just to give you a quick recap of where we're at, we are on page 124. We're on the last week of content. We're looking at reactions. Now, we've looked at alkane reactions, we've looked at alkene reactions, so they're substitutions and additions. We've looked at haloalkane reactions, which is going to be a substitution if it's NaOH, and it's going to be an elimination if it is an ethanolic NaOH, so that's ethanol with alcohol. So if we see ethanol with sodium hydroxide, sorry. So if we see those things together, we know it's an elimination. I can't get my words together. In this video, we're going to look at reactions of alcohols, and there are two that you need to be aware of, which are fairly simple. A lot of the products are very, very similar, and you'll be able to work out the pattern once I've shown it you. You can read all this information here, and I strongly recommend it. And then what I'm going to do is I'm not going to read it to you, I'm going to show you some actual reactions. And you can see here in purple, these are the bits I'm going to show you how to do it, and then I want you to have a go of yourself. This will give you the understanding of what's actually going on, which I'm sure you can read. So for the task, the following reactions, you need to complete a balanced equation using displayed or skeletal. I'm going to use skeletal for the video, and write a balanced equation using a molecular formula. So what I've highlighted in blue is alcohol is going to have two reactions. One with phosphorus pentachloride, and the other one with HBr. That's it. These are the two things you need to be looking out for. One, is it an alcohol, so it has an OH? Two, what is that OH reacting with? Is it PCl or HBr? Because the results are going to be different. So let me show you what the first one looks like. When we're reacting it with a HCl, I'm just going to draw it out in skeletal. So I'm going to draw my 3 carbons first. I'm going to go 1, 2, and 3. And then on that second carbon, so carbon number 2 is an alcohol. I'm actually going to substitute that alcohol with one of those chlorines, just the one of them. So I'm going to put that there. Now this is going to be the main thing I'm interested in. That's my main product, so I've done that substitution straight away. The other products are the same always, and you need to just remember them. So once you've done the problem, there's the problem, you now then need to add the rest. So our final products are just going to be POCl3, so you notice I'm missing a chlorine, plus HCl, the acid. Let me fix the L. There we go. And these two, so long as we have PCl5, they're always going to be the products. So that's never going to change. This depends on what we react with here. I would like you guys to write the molecular formula, make sure it's balanced, and put it there for me. There is no stoichiometry here, so no big numbers. You don't need to worry about that. Question number 2. This time we're going to be reacting it with HBr. So again, it's another substitution, but the products are going to be different. I want you to actually draw the products as substitution, but what I'm going to do for you instead is I'm just going to write out the molecular formula of this, and I'll even be charitable enough to give you the molecular formula of our products. So let's start off with this. We've got an alcohol, and if you remember from our general formula, we're going to do CnH2n plus 2O. There are 2 different ways of writing this, but I'm going to use the easy way just to show you. So I've got 1, 2, 3, 4, 5 carbons. So that's C5. H, double it, add 2, is 12. And then O, because it's an alcohol. The other answer I will accept for this is C5H11OH. This way we do prefer, but you make more mistakes. This way is correct. Plus HBr, really simple. There's our conditions. I've got an alcohol with a HBr. What am I going to produce? I'm going to have a substitution. So what I'm going to do is I'm going to substitute the OH. So I'm going to swap the OH around for a Br. With this method, it's very easy because you just get rid of this bit and put Br. For this one, you have to do a bit more work, which is why I kind of want to show you both so you can pick which one you prefer. So for the substitution, carbons stay the same, C5. This time, it's going to be H11Br. The other way you could do this mentally is knowing that if you substitute it, you're going to make a haloalkane, and a haloalkane has the general formula, double it, add 1. So you can work it out that way as well. Remember, if you're going to go to this way and use this route, you can see that over here, when I go C5H11Br, all I've done is I've kicked out this OH and replaced it with the Br. So there are pros and cons to using both. That's not it though. So because I've used HBr, I'm also now going to produce H2O. If I use HBr with an alcohol, I always make H2O. So that's never going to change. That'll always be the same. What I would like you to do is, can you draw the correct product and make sure that you draw the branches in the right places and the alcohol replacement in the right place. For question number 3, you can see I'm going to do something similar, but I'm going to take over this bit for you, and I would like you to draw the product and write the molecular formula for the products, plural. Over here, I've got what we call a diol. It's called a diol because I have 2 of them. Now, I'm going to count the carbons. I'm just going to go 1, 2, 3, 4, 5. I've got 5 carbons just like before. The general formula for this doesn't work because I've got a diol, so it's different. So I'm going to go C5, and I'll show you where my hydrogens are now, just so you can see this, because I don't want you to get mixed up. Then I have 1 here, 3 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This carbon over here has got 3 bonds, so one of them must be a hydrogen, 11. And then this carbon over here, 1, 2, 3, 4 bonds, which means that is the maximum amount that I have. So just so you can see where my counting is again, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C5H12. Oxygens, I've got 2, so it's going to be O2. Plus my reactant, which is PCl5. If I have an alcohol and I have PCl5, what happens next? Unlike last time, PCl5 will only do 1 substitution. So you can have as many alcohols as you want, but I've only got 1 PCl5. So I'm only going to have 1 substitution. If I had 2, I could do 2 substitutions, and we could do it that way. And that's it. I'd like to have a go at this, see how you feel, and again, if you're feeling confident, have a go at using the IUPAC nomenclature to name them.